Welcome to Tales at Scale, a podcast that cracks open the world of analytics projects. I'm your host, Rita from Imply, and I'm here to bring you stories from developers doing cool things with analytics way beyond your basic BI. I'm talking about analytics applications that are taking data and insights to a whole new level. Today, I'm actually rolling solo as I dive into the ins and outs of the multi-stage query engine for Apache Druid. The work around the multi-stage query engine started long before its release in Druid 24, which happened in 2022, and has fundamentally changed what Druid can do. The funny way to say it is this is like a whole new shape for Druid, not to be a little too on the nose. But what does that even mean, right? What changes need to be made? What are the benefits? Basically, why was this built? But let's go back to November of 2021. Gian Merlino, a committer for Apache Druid and CTO and co-founder of Imply, announced Project Shapeshift, which was a multi-phased initiative designed to shift and improve the Druid experience in a cloud-first, developer-centric world. There were three key goals for Project Shapeshift. Cloud native, with the goal of being to enable a true database as a service that was built from Druid. Checkmark here because that's Imply Polaris. Simple, which is pretty self-explanatory, improving the overall ease of use across Druid, and then complete, which in this case means expanding Druid architecture, making it the most capable database for analytics applications. For the purpose of this discussion, I'm going to focus on the latter two. If you're familiar with Druid, you probably already know that it's great for a slice and dice at scale, but some analytics applications need a bit more, right? One thing they need is longer running queries and more complex queries. And this previously could sometimes pose a bit of a challenge for Druid, if I'm being totally honest. The same broker process that enables sub-second performance across petabyte queries can also, for some other queries, become a bottleneck. So the old workaround was to use other systems alongside Druid, but that's a pain because now you're loading the same data in two locations, you're creating two separate pipelines, you're adding complexity, and with that comes added cost. But in 2022, the dedicated Druid community changed all that with the introduction of a multi-stage query engine. But the work that went into building that engine actually enabled some other helpful features, like the ability to run queries and ingestion using a single system and single SQL language. So this eliminates the need to have two separate operational models for ingestion and query execution by allowing developers to query external data and enable deployment modes with separate storage and compute. So this new functionality has literally transformed Druid, I'm probably going to say that a lot, and sets it up to be the real-time analytics database that will work for pretty much all use cases. A good way to think about Druid today is that Druid is a garage, right? And you have two vehicles inside. One is a Ferrari, because in this scenario, you are independently wealthy and thriving. And the other is a Suburban, right? Because that's the biggest vehicle I can think of off the top of my head. The Ferrari is super fast, but the space inside is limited. So that is not what you're going to be using to help your friend move. No amount of pizza or beer will get you to do that. But the Ferrari is Druid's core query engine. It's fast. It's great for interactive queries. But next to it is your big, huge SUV that fits 7 to 8 people or 6 people and 3 to 5 dogs, depending on the size of the dogs. You can put a lot in here, but it's not as fast. That's the new multi-stage query engine. It's built to move large amounts of data. It also enables SQL ingestion, long-running queries, long reports, but we'll get into that. The point is, you have a choice for when you need to move lots of stuff, data, and when you need lots of speed. Previously, Druid was just the Ferrari, but nobody is sad about it being a Ferrari. But now you also get the multi-stage query engine / Chevy Suburban as well. Actually, I'm kind of downgrading it by calling it a Suburban because it's actually more like an 18-wheeler. But I liked my garage metaphor. And also, no one wants to see a truck that big going really fast down the road. Okay. But I digress. Let's get back into it by going a little bit back. I think Gian actually explained it best, so I'm just going to quote him here. Druid doesn't load data from disk to memory or from memory to CPU when it isn't needed for a query. It doesn't decode data when it can operate directly on encoded data. It doesn't read the full data set when it can read a smaller index. It doesn't start up new processes for each query when it can use a long-running process. And it doesn't send data unnecessarily across boundaries or from server to server. So what does that even mean? Druid achieves its high level of efficiency through tightly integrated query engine and storage format, designed in tandem to minimize the amount of work that each data server has to do. If you've worked with Druid, you know that one of the key elements is that it's distributed. Druid's distributed design partitions tables into segments, balances those segments between servers automatically, and then quickly identifies which segments are relevant to the query, and then pushes as much computation as possible down to the individual data servers. But that brings us to that broker. So the broker is the query entry point, and Druid uses scatter gather to execute queries, which works pretty much like it sounds. It sends a little bit of the query to relevant data series, then gathers up the results from each, merges them together, and then returns the result to the user. And that is fantastic for common queries. And this technique enables Druid to scale from running on a single server or laptop to petabytes of data served by thousands of data servers. This also means that the broker isn't dealing with the large amounts of data. It only needs to pull together the query results returned by the data nodes. So the broker can handle a query that spans thousands of data servers and billions or trillions of rows. So what's the problem? The broker can become a bottleneck, like I said. This can happen when the query results are very large or when a query needs multiple passes over the data. Let me give you an example to kind of tie this all together. If you have a table with 1 billion events and you query, let me say, how many events happened last Tuesday between 9 and 10 a.m. that were marked important, then the broker will scatter the query across the right segment in the data nodes, and then gather the results to give you an answer, which might be, 37,100,392. Druid will usually do this query in under a second, right? But if instead you need to query, give me all the results from, last Tuesday between 9 and 10 a.m. that were marked important, and then Druid needs to return 37 million rows, that can overload the broker. If each row is 1 kilobyte, you're talking about over 37 terabytes of data on return. It won't happen in under a second, and actually it might cause the whole query to fail. But sometimes we need Druid to provide these sorts of data exports or long downloadable reports. So what was the solution? It's actually shuffle mesh, which I think is fun to say, and I know this is coming out on Valentine's Day, and I'm trying not to make some sort of Cupid shuffle joke because I actually don't know how to do it. But anyway, I'm getting off track. With the multi-stage query engine, Druid has a system that splits queries into stages and enables them to be exchanged in a shuffle mesh between the stages. Each stage can run in parallel across many data servers at once. Druid now runs multiple broker processes, automatically using skew-resistant shuffling and cooperative scheduling, so you're not doing any tuning. So by allowing each stage of the multi-stage query to run distributed across the shuffle mesh of brokers, you can efficiently carry much larger sets of data through all the stages of the query. So you don't get that bottleneck that we talked about. But you can also, by the way, keep running single stage queries if you need to. They'll execute using the same fast and efficient scatter-gather technique that Druid has always been used for. So that's still available. So now that we've kind of tackled the broker bottleneck, why stop at just having a shuffle-capable query engine for doing just queries? That's boring, right? Go big or go home. The multi-stage query engine also has helped reimagine Druid's ingestion. Think of ingestion as a query that reads external data, clusters, partitions it, and then writes the result to a Druid table. Before the release of Druid 24, in order to load data into Druid, you'd need to learn to use Druid's ingestion spec. While the Druid console makes this not too hard to do, it was still a bit of a pain though, because let's be real, more developers are familiar with SQL. Now you can use SQL queries to load data into Druid thanks to the multi-stage query engine. So to ease the transition into the new engine, it's now easier to connect with data sources like CSV or Parquet or protobuf files. parse the incoming data schema, and generate the SQL query to copy the data into the Druid tables that you want. The web console also has a new query editor, and it comes complete with feature tabs because who does not love an organized workspace? I know that I do. So this isn't easier than using classic ingestion spec, right? Batch ingestion with MSQ-powered SQL is actually significantly faster. Another data source you can use is existing Druid tables. So you can transform data actually inside of Druid. But the biggest benefit here is that data and transformation on ingestion and inside of Druid from one table to another using SQL actually makes Druid about 40% faster. The new multi-stage query engine powered SQL batch ingestion is actually what we now recommend as the method to load batch data into Druid. That's all that's happening right now. That's all that's already happened. That's stuff that's already available in Druid. But now I'd like to shift to what is coming next to give you a preview. As I said before, the multi-stage query engine has enabled a lot of other features, right? And a lot of other functionalities. So everything I mentioned is in Druid now, but here are the things to keep an eye out for upcoming releases. The first one I'm going to talk about is cold tier or cold storage, which will let you choose which data you need at high speed and which you don't to save money. You'll be able to query Druid tables or, say, like parts of tables based on time to exist only on Druid's deep storage tier. Now, normally every Druid segment has a copy in both deep storage, which is cloud object storage like Amazon S3 or Azure Blob or Google GCS, or if you're off the cloud for some reason, HDFS cluster, and on the data nodes, which we talk about being the Ferrari, right? For the data that you designate for cold storage now, the only copy is on the reliable, but obviously slower, deep storage, which is the SUV. It's much less expensive, but queries will also then be slower. So that's kind of the trade-off. But even though it's slower, it's still Druid segments, so it still has all the indexing and dictionary encoding and compression that make Druid so fast. That gives you the full power of Druid for any sort of query, and then Druid will figure out automatically the best way to access each segment it needs, whether it's the Ferrari of the Druid data nodes or the SUV of the Druid cold storage. So it's choosing your vehicle for you. The benefit here is that it makes Druid much less expensive and it uses less infrastructure. But again, like I said, the trade-off is it's a little bit slower. Not like terribly slow, just a little bit slower, right? That's not so bad. But not everything needs to be at top speed anyway. I mean, one thing we talked about on the show before is who needs real-time data and who doesn't. And even if you do need real-time data, you'll likely only need it for like a certain time frame or else, it's not real time. So what do you do with the rest? Say you're working with a data stream that delivers a terabyte of data each day. You may find that 98% of your queries only need to look at the last 90 days at any given time. So that's loaded on the data nodes for your sub-second queries. But for data that's 91 days or longer, you can put that in deep storage. How often do you need to look at data from like the last 5 years, right? Likely once in a while, like at best. But if you find 90 days is too long and you need the data for, say, like the last 60, you can obviously change that. Or you can change it to 120 days if you need more. Or you can set different rules for different tables. You get to choose the data you need at high speed and which you don't, which saves you money. So that's cold storage, and that's coming. The next big thing I want to talk about is asynchronous queries. So let's say if you're going to do a query against a petabyte data set, say it's a trillion log entries, and you want to ask how many log entries came from a particular application. It's going to scan a lot of stuff and it will send back a number. But this gets harder when you're looking over the entries and want to send back all of the entries in the table that deal with this application and then put them in order. Say you're going to put them in order by country. Let's say you get 10 million results that you need to then organize by country. The system will find and pull those 10 million, and then you can put it in groups by country. But this is another case where you may create a bottleneck. So we're going back to our good old friend, the broker. When the answer is a whole lot of data rows, the broker can become overloaded, as we talked about. With Shuffle Mesh, The team of brokers create and shuffle the data across the mesh. So instead of one broker, trying his best, they work together to pull it together and organize it in the way that you're asking. This also changes how queries time out. With asynchronous queries, each query can run for as long as it needs to complete, since you're no longer dependent on that one single broker. This means that you get to run longer queries. With scatter gather, if you've experienced it before, it can definitely time out, right? Now it will update you and give you a percentage, like X% complete. If you're doing a really complex thing, it could be like 0.001% complete after a minute, and then that gives you the opportunity to decide if you want to keep going or cancel it. So that's coming soon to Druid. Now, the next thing I want to talk about is a big myth, actually, that I'd love to bust on this podcast. Love a good myth busting. One thing that has plagued Druid for ages, it seems like, is that it can't do joins. But that is not true. You heard it from me. It is not true. Joins have been a part of Druid for a while. But coming this year, Druid will be able to do much more complex joins. In a data schema environment, there are usually fact tables and dimension tables. So a fact table has millions or billions of rows. So maybe that's orders or customers for a large enterprise. A dimension table usually has like a few hundred to a million or so. Maybe that's a table to convert, the abbreviation of state names in the United States, which is, actually more than 50 if you count DC and Guam. Anyway, in Druid, we do joins between fact tables and dimension tables. But what if you want to join a fact table to another fact table? Well, then you're just going to time out, right? Once more, you're creating a broker bottleneck, but moving forward, you'll be able to do much more complex joins as Druid uses the multi-stage query engine shuffle mesh there. Also on the horizon is SQL stream ingestion. And just like batch ingestion, it will be simpler with SQL commands. So to reiterate, with the addition of the multi-stage query engine, Druid gives you now 2 fancy vehicles to cover all your data driving needs. And again, this is just the beginning of the whole new Druid. We're kind of just getting started here. So this is the time where I usually thank my guests, but since it's just me, I instead will say I'll be back to catch you up on the latest Druid features, improvements, and fixes. In the meantime, if you want to learn more about any of Druid's new capabilities, you can visit druid.apache.org for more info. And if you need help getting up and running on Druid or need support, you can visit imply.io. Until then, keep it real.